Stoichiometry Part 2. In Part 1, we had seen how to write a balanced chemical equation and then using the coefficients in the balanced chemical equation to write mole ratios. These mole ratios could be used to find the amount of any substance in the chemical equation if we know the amount of another substance. So mole ratios are useful for converting the amount of any substance to any other substance between two substances in a chemical equation. In this part we will see another aspect of stoichiometry, that is limiting reactant and theoretical yield. Usually when we have a chemical reaction being done, we do not measure out all the reactants in exact mole ratios. We always mix certain grams or certain volumes of the reactants and the reaction is done. So we are not sure whether the reactants are taken in exact mole ratios so that at the end of the reaction all the reactants are completely used up and all the products are completely formed. Usually the situation is that one of the reactant may be more than that is required for the other reactant to completely react. So we need to find the limiting reactant or the reactant which is in smaller amounts, so that when that reactant is finished or consumed completely, the reaction will stop even though the other reactant may still be present. It is important to find the limiting reactant because only if we know the quantity of the limiting reactant, we will be able to exactly calculate the quantity of products formed using the mole ratio that we studied in Part 1. So let us see an example and we will understand how the limiting reactant works and how we can find the limiting reactant in a particular chemical reaction. Suppose we react 2.8 grams of solid aluminium with 4.15 grams of chlorine gas. To produce aluminium chloride, AlCl3, that is aluminium chloride. We need to determine which is the limiting reactant in this reaction and the theoretical yield of the product when this reaction is done. How to do that? First, we will write the balanced chemical equation of the reaction between aluminium solid and chlorine gas, giving aluminium chloride AlCl3 solid as the product. We need to balance this because there are 2 chlorines on the reactant side and 3 on the product side. So we need to put a 2 here and a 3 here in order to balance the chlorine. And when we do that, we need 2 aluminium on the reactant side. So this is the balance equation. Now, first what we have to do is to determine which is the limiting reactant. Step 1. Determine the limiting reactant. For this, we have to convert the grams of aluminium and the grams of chlorine gas to moles of each. So 2.8 grams of aluminium is equal to how many moles of aluminium? how many moles of aluminium. For that, we will make use of the atomic mass of aluminium and the equation number of moles is equal to mass in grams divided by molar mass. So the mass in grams of aluminium in our reaction is 2.8 grams divided by the molar mass of aluminium is 26.98. So this is the number of moles of aluminium. This is equal to 1.04 into 10 raised to minus 1 moles. Similarly, we have to find the number of moles of chlorine gas. Using the same method, we can get number of moles of chlorine from 4.15 grams of chlorine gas is used in our equation, in our reaction, is equal to how many moles of chlorine gas. Number of moles, we use the same equation, that is equal to mass in grams of chlorine divided by molar mass. That is equal to 4.15 gram divided by 34.5 plus 34.5, that is 79 molar mass of chlorine, and that will be equal to, the mass of chlorine gas is 35.5 plus 35.5 because there are two chlorine atoms in that, so it will come to 70.9, or let us say 71. So the number of moles of chlorine we get will be equal to 5.85 times 10 raised to minus 2 moles. So this is the number of moles of aluminium and this is the number of moles of chlorine that is being used in our reaction. Now we need to find out which is the limiting reactant. In order to find the limiting reactant, there are a number of ways. Basically 3 methods are there, but the easiest method is using the mole ratio, find the moles of aluminium chloride that will be produced if 2.8 grams of aluminium is completely reacted. Using the mole ratio 1.04 10 raised to minus 1, find out how many moles of aluminium chloride can be produced. Next, you calculate the number of moles of aluminium chloride that can be produced using 5.85 times 10 raised to minus 2 moles of chlorine. Whichever is the smaller value, whichever gives the smaller number of moles of aluminium chloride, that reactant will be the limiting reactant. So let us do that calculation. According to the mole ratio in the balanced equation, the mole ratio between aluminium and aluminium chloride is 2:2. So the mole ratio between aluminium and aluminium chloride, that is equal to 2/2. So 2 moles of aluminium will produce 2 moles of AlCl3. Therefore, 1.04 moles of aluminium will produce 2 times 1.04 times 10 raised to minus 1 times 10 raised to minus 1 divided by 2 moles of aluminium chloride, which is equal to 1.04 times 10 raised to minus 1. So that is the number of moles of aluminium chloride that can be produced using 2.8 grams of aluminium. Moles of aluminium chloride that can be produced. from 2.8 grams aluminium is equal to 1.04 times 10 raised to minus 1 moles. Similarly, the mole ratio of the chlorine gas to aluminium chloride in the balanced equation is Cl2 by AlCl3 is equal to 3 by 2. That means 3 moles of chlorine gas can give 2 moles of aluminium chloride. Therefore, 5.85 times 10 raised to minus 2 moles of chlorine will produce how many moles of aluminium chloride? That will be 2 times 5.85 times 10 raised to minus 2 divided by 3, which is equal to 3.92 times 10 raised to minus 2 moles. So when you compare the number of moles of aluminium chloride that can be produced from chlorine gas in the reaction and the number of moles of aluminium chloride that can be produced from 2.8 grams of aluminium according to the reaction, chlorine gives smaller number of moles. Therefore, chlorine is the limiting reactant. Therefore, chlorine is the limiting reactant in this reaction. In this particular reaction only, because the amount of chlorine taken will be fully consumed by the amount of aluminium that is taken, and there will still be some aluminium remaining after the reaction. So chlorine, when it finishes completely or is consumed completely, will stop the reaction. That is why it is called the limiting reactant. And the yield of AlCl3 produced from the chlorine is called the theoretical yield. That is 3.92 times 10 raised to minus 2 moles, which we can convert into mass by multiplying by molar mass. So theoretical yield is basically the amount of product formed when the limiting reactant is fully consumed in a reaction. That is the theoretical yield. So the theoretical yield in this case is 3.92 into 10 raised to minus 2 times the molar mass of aluminium chloride. That is the one that is produced. We are getting 3.92 into 10 raised to minus 2 moles of aluminium chloride, which we have to convert it to mass of aluminium chloride by multiplying with the molar mass of aluminium chloride. So molar mass of aluminium chloride is, molar mass of aluminium chloride, which is actually 133.33. Therefore, the theoretical yield in grams, it will be 5.20 grams of aluminium chloride. So this is the limiting reactant and theoretical yield calculation. Thank you.